Okay, so hello everybody again. My name is Claudio Morana, and I'm the director of CefES, the Center for European Studies at the University of Milano Bicocca. CefES is hosted by the Department of Economics, Management and Statistics of our university. It was established in 2018 as one of the pillars of a 5-year project funded by the Italian government. Since inception, the center has been very active in research on European issues and its dissemination. There are currently 17 active research projects related to the impact of COVID-19 and the broad areas of energy markets and climate change, macro and finance, governance and cooperation, management, history and law. CefES gathers scholars from different fields in economics, political science and law with the objective of contributing to the empirical and theoretical debate on the European economy. We invite contribution from external researchers to current center's activities or new initiatives in quality of external fellows. We also recently started an internship program. We have planned 2 workshops in the coming months. The first workshop is focused on the future of European integration. The date is November 16, and it will be soon advertised through our mailing list. So you will receive information. And the second workshop is focused on the future of capitalism in Europe, and the date is December 13. Information on this workshop also will follow. And please visit our website for additional information on all our activities. Today's webinar is a part of a joint CefES-JRC scientific initiative. We are proud to carry on this initiative with the aim of connecting scholars all over the world and to strengthen their cooperation, particularly in this period of high human, social, economic, and political distress. Before introducing our today's speaker, I would like to give the floor to Dr. Mario Bellia of the Joint Research Center of the European Commission for his welcome remarks. Mario, you have the floor.
Thank you very much, Claudio. I'm very much delighted to welcome the audience on behalf of also of the Joint Research Center of the European Commission, which is co-organizing this event together with the Center for European Studies. The JRC, the Joint Research Center, is the knowledge and research arm of the European Commission, which supports the EU policies with independent evidence throughout the policy cycle. We are also active in the field of sustainable finance and climate risk, as in the topic of today. Notably, our researches focus on the integration of sustainability in the regulation of financial institutions and provide scientific evidence to support the initiative to accelerate the role of sustainable finance for the transition of the real economy. I'm thus happy to co-chair this presentation with Claudio on risk for climate change. This is it. Thank you very much, Claudio, and I will enjoy your talk, Stavros, and back to you, Claudio.
Thank you, Claudio, very much, and Mario, it's really a great pleasure to be here, and thanks to CefES for inviting me. And this reminds me to remove my CV from the web so people do not read it during introductions, but I appreciate the invitation, Claudio. So what I will discuss today is a policy paper that I wrote for Bruegel on climate risk for sovereign debt. I will talk about the climate risk exposure of European sovereigns, basically to understand at some general level what are the EU vulnerabilities and what is the readiness of EU sovereigns, but more importantly, to understand the transmission links from climate change to fiscal risks. Then I will discuss a little bit the evidence of pricing of climate risk in sovereign debt markets to understand if this phenomenon of climate change is having an effect on the markets. And finally, that's the essence of my talk today, not necessarily of the policy paper, is how to deal with these complex issues. I will suggest how to use the scenario matrix architecture of the Intergovernmental Panel of Climate Change to conduct the sustainability analysis. And I will go a little bit into a model we have developed. And I've seen all of the participants was a colleague of mine in developing the model several years ago, Angel Gavilan. Hi, Angel, if you're there. And show how we can integrate this kind of models for the sustainability analysis with climate science models for climate risk. So I will spend some time on this box here, and then I will make the kind of the policy recommendations of the paper to climate-proof sovereign debt. Now, in case I lose some people of the audience along the way, or you get lost in some of the modeling issues, let me give you the punchline. This is kind of towards the end of the talk. I'm going to present this picture. And what is this picture saying? This picture is to understand the risks to the Italian sovereign debt due to climate change. What you have on the vertical axis is the debt to GDP ratio for Italy after the pandemic, which is quite high. The pink shaded area is the fund chart of the debt sustainability analysis we did for Italy over a 60-year horizon. Given interest rate projections, given fiscal positions, given growth, we observe that the Italian debt, the median, the 50% red line, it's declining from its very high levels, but it's stabilizing at about 150%, with a significant upside risk. There is more than 50% chance probability that the trajectory of the Italian debt will keep increasing. Now, what we did was to take this basic stochastic debt sustainability analysis and superimpose it with a climate science model. So the blue lines you see here are the three quantiles, the median, the 75 percentile, and the 25 percentile, using a WICH model, the model called WICH from the climate science community, that models the effect of climate change to GDP for the case of Italy. And now you see that even the median is not stabilized, and the upside risk is becoming even higher. Now, we do the same analysis with an alternative model, the RISE 50, it's a kind of an evolution of the famous Nordhaus DICE model. And now I show you only the median. And the median, again, you see the dynamics deteriorating, although not as much as with the WICH model. Now, this is kind of some of the insights we will get from today's talk, how the debt dynamics of a country are affected adversely from specific climate change models. Now, I ran the climate models under some scenarios, and that's something I'm going to discuss. But from this slide, some of the big challenges are already surfacing. The problem of climate change and its effect on fiscal position is a problem of deep uncertainty, as the climate science community is saying. Deep uncertainty means there are some things that we know probabilistically. This is risk. Everything what is pink here is a risk. We know what to do with it. We have distributions, we have probabilities, we can deal with this. Then there is ambiguity. The blue lines are ambiguous. We know more or less what the world will look like if we satisfy the Paris Agreement goal of 1.5 or 2 degrees temperature increase, but we have no idea if we are going to meet these goals. So we have scenarios, but we don't have the probabilities. This is ambiguity. And finally, we have what people in the climate community call misspecification. How exactly do you specify your model? And here there is a big discussion. As you see here, we're using two prominent models, WICH and RISE, and they differ quite significantly from their predictions. It is not that one of them is wrong and the other is correct, that would be too easy, is that we're not quite sure. So there is some missing aspects of the specification. So we will see what to do with this. But let's take this from the beginning. What is the climate risk exposure of European sovereigns? Now, I took the Notre Dame Global Adaptation Initiative, and they published two indices, a readiness index, how ready is a country to leverage investments to adapt to climate change, and a vulnerability index, how predisposed is a country to be negatively impacted by climate hazards. All these points you see there are the various countries of the world that are covered by this Notre Dame database. And I highlight here the Eurozone, the EU countries. Those that are missing are somewhere hidden here. So I just put a few select. And we see quite positively that European Union countries are among the most ready and the least vulnerable. However, as you will see in a moment, we are not off the hook. The vulnerabilities could be quite significant, but I also wanted to point out from this picture another reality, that some of our neighbors in the region, Egypt, Libya, Syria, etc., they are less ready and more vulnerable. So there is friction in the boundary. So it's not just enough for you to be ready and not vulnerable, but if your neighbors are less prepared and more vulnerable, this is a source of friction and potential political instability, which is one of the topics that Claudio mentioned earlier, is close to my heart, understanding political risks and their effect on financial or fiscal variables. Now, we took one of the prominent models published in Nature 2015 by Bruegel and Miguel, and here is the kind of change in GDP per capita in Netherlands, Belgium, and France at the top, Italy, Spain, and Greece at the bottom. In case anybody knows, anybody's interested, I also have Cyprus here in the corner. Oops, I missed my slides. Okay. And what you observe from this, and that's an important point that keeps coming up in the policy paper, is that climate change has the potential of creating a new North-South climate divide in the Eurozone, in the European Union member states. Some countries are affected much more than others. We even have expectations that some countries could be affected positively in their GDP per capita. It's a long discussion on this, but you see the divergence. So one of the arguments I'm making in the policy paper is there is an exogenous shock, which is a global shock, is nobody's fault from the member states. This exogenous shock creates potential divergence, and like we have seen in the case of COVID, we need some common action. Now, I put this slide because it's kind of striking the differences, but I have to put a footnote here, an important footnote. This is under the worst case climate change, where we do nothing and the temperature keeps increasing at the worst possible scenario. It makes the picture more dramatic, but in reality, even if we use a more modest scenario, like the meeting the Paris targets, and a more recent model, the deviations are still here. What we observe here is the proportional reduction of GDP growth from 2020 to the end of the century. And you see countries like Denmark, Finland, they will suffer losses by 25–30%, while on the other hand, you see Bulgaria, Greece, they will suffer losses of 70%. So again, this potential climate divide is emphasized with alternative models as well. And this is not the usual North-South divide, but also includes in the susceptible South many Central European countries that are more exposed to assets that are likely to become stranded, like coal. Okay, now let's understand how climate risks are transmitted to fiscal risks. Okay, so what I show here is that the green are the climate modules. Greenhouse gases, concentration of greenhouse gases creates both extreme weather events and long-range change, like sea level increase or temperature increase. Now, what comes out of these boxes is what the climate science community and the Intergovernmental Panel of Climate Change calls narrative scenarios. We describe what could potentially happen using narrative scenarios, like we follow the Paris Agreement or we do not follow, and we follow successfully or we follow at some intermediate level. Now, out of these extreme weather and long-range changes coming from climate science models, we have physical risks like flooding that we had in Germany this year, or fires like we had in southern Italy and Greece. But at the same time, because of these changes, we take mitigation steps. And again, mitigation steps, mitigation policies are driven by narrative scenarios. Do we respond immediately, or do we respond more forcefully sometime down the road? These mitigation steps create transition risk, transition to a low carbon economy. So the transition risks and the physical risks are mediated through adaptation policies. How do the economies or societies prepare to adapt to both extreme weather and long-range changes? So again, this is policy here. And mediated by the policy, we have an economic module of the damages and an economic module of economic transition. These modules feed into the economic dynamics, and the economic dynamics feed into the debt sustainability. They determine things like the fiscal needs, the debt, the economic growth of the country. They also feed into financial variables like the real rate of interest, R star, or inflation, or asset revaluation. And these are the components, these are the elements that we use to do stochastic debt sustainability analysis, to understand the debt dynamics. So basically, we have the green modules that are coming out of climate science models. This is the integrated assessment models that the climate science community has been developing for us. And these modules are run under various narrative scenarios. And I will discuss later how to put some structure in these narrative scenarios. Then you have the policy modules, mitigation, adaptation. And again, these are described by narrative scenarios. And once we fix the narrative scenarios, we can get projections of damages, the economic transition, and then feed everything into our understanding the fiscal positions. So the main point I'm making in the policy paper is that the same way the network for the greening of the financial system looks at understanding the implications of climate change to financial stability, in the parallel effort, we need to understand the effects of climate change on fiscal stability. And this flow chart here sets the basic elements of our understanding. Okay. Now, to understand these blue modules, to link the green with the yellow and the blue, I'm going to rely on forward-looking scenarios. There has been an interesting convergence between the climate science community and the data analysis community over the last several years. We both tend to work using forward-looking scenarios because climate change, people take a very long horizon and they have to understand future scenarios. And because debt sustainability, stochastic debt sustainability hinges on uncertainty, so looking at scenarios is an important element, and that's part of the contribution that we made working with the European Stability Mechanism in developing a system. So we look at forward-looking scenarios of GDP growth, of fiscal variables, including mitigation cost, adaptation cost, damages, the financial variables, namely R* and inflation. And here I need a pointer to all the great work done by the central banks, especially European Central Bank and Bank of England, in understanding the effect of climate change on financial stability. So some of the things we need to understand the cost of sovereign debt financing is already taking place at the central banks. Okay. Then we have to look at asset revaluation and contingent liabilities. To what extent the sovereigns finance some of the damages as contingencies. And indeed, countries like Japan, Australia, and New Zealand, part of their budget involves contingent liabilities coming out of climate changes. So, number one, forward-looking scenarios. Number two, narrative scenarios. Some of these things I can model and I can get their probabilities, but some of the things I cannot. I just can have a narrative, like on damages, on adaptation, on mitigation. Depends what policy a country will follow. We have to model both the acute and the chronic effects. Acute is extreme weather, chronic is the gradual changes. And finally, we cannot rely on only one model because there is misspecification. So we need to work with ensembles of climate integrated assessment models. As you will see later, there are some disagreements, and these disagreements somehow we have to incorporate in our analysis. Okay, let me now digress for a second, but an important digression. Is climate risk priced in the sovereign debt markets? Well, the evidence is mixed. I think it's only recently that the markets are becoming aware of the risks and start pricing it. But a very strong evidence is coming from a just published paper coming out of Bennett Institute of Cambridge. Mohades and his colleagues, they used a machine learning tool to develop a credit rating model that uses, among other things, GDP growth as part of their credit rating variable. And they link this model with an integrated assessment model, and they develop a map, like you see two maps here. The map on the top right shows the down ratings of countries all over the world with a temperature increase, the RCP 2.6. This is the representative concentration pathway 2.6, which is about 1.5 to 2 degrees temperature increase. This is the Paris Agreement. The bottom right is RCP 8.5. This is much higher greenhouse gases concentration. This is if we do nothing. And by running their analysis, they find, if you look at the comments here, that under the Paris Agreement, there will be 55 down ratings by slightly, about 1 notch, less than 1 notch. Under the do nothing scenario, there will be 80 down ratings by 2.5 notches. European Union member states appear in both cases, so we are not safe. As you see here, we're coded, we're colored, although the downgrading is small. Okay, and downgrades start from 2030. So the effects of climate change on a sovereign's ratings are not very far down the road. This particular model shows that from 2030, you already see results. Now, you may have not noticed, but the first picture I showed you, these fun charts, the shift of the debt up with climate change again starts about 2030. So my analysis and their analysis, using totally different methodologies and different data, they converge to the same observation, that from 2030, we start seeing the effects of climate change on sovereign debt. Okay, now there is an open question here. What are the markets pricing? Are the markets pricing the effects of climate risk on an issuer, or are they pricing the effect of an issuer on the climate? When you look at all this literature on ESG pricing, ESG investing is about investors being sensitive to what an issuer, if an issuer is environmentally sustainable and governance correct, right? It has nothing to do with what the climate may do to an issuer. A country like Cyprus, for example, can be perfectly environmentally sensitive, perfect governance, perfect sustainability, but still will be hit a lot by climate change. I'm not saying we are ESG perfect, but I'm saying that even if we were, we would be hit really bad by climate change. While a country like Germany, for example, may be doing everything wrong on ESG issues, but will be hit much less. So what are investors pricing when they invest in these two countries or in two companies? Are they pricing what the country does to the climate or what the climate does to the country? This is a big question here, and I think it's worth investigation. Okay, now let me go to the climate risk framework for debt sustainability. Now, to look at the debt sustainability, we have to look at two variables. One variable is the debt stock. How does debt evolve with time? And I give you here the fundamental equation of debt stock. Stock at time period t is a function of the stock at the previous time period times the interest rate you pay on your debt minus primary balance. If the country is running a surplus, debt stock is going down. If primary balance is negative, then the debt stock is going up. So that's one variable. The second variable is the debt flow. How much do you have to pay in terms of interest? That's the first term. What is the amortized debt that you have to finance at a specific point in time? And again, the primary balance. But of course, the debt stock and the debt flow variables are scaled at a proportion to GDP. So what matters at the end of the day is the debt stock to GDP and the debt flow to GDP. Now, remember these very simple equations because I will use them again at the end. It will be part of the final exam. So these are the two key variables that we need to keep in mind. So now we're going to go back into this flow chart and try to understand as much as possible. And we're still at the preliminary phase. So, I mean, we have done some work, but much remains to be done in understanding the effects of the green and the yellow boxes by variables. Okay? That's where the narrative scenarios are coming in. Narrative scenarios work on two axes. One axis is what I show on the top right. These are the representative concentration pathways. What is the concentration of greenhouse gases in the atmosphere, and what is the resulting temperature change? These are the RCPs. On the left is what they call shared socioeconomic pathways. What socioeconomic pathway does a society follow with the related socio-adaptation challenges and mitigation challenges? For example, if we take SSP5, fossil fuel development, we have no problem of adaptation, but we have huge problem of mitigation. Okay? On the other hand, if we take, let's say, right, SSP1 is the sustainability scenario. We take efforts to adapt, to mitigate, and therefore the challenges under this scenario are likely to be lower. And SSP2 is considered the middle of the road. So that's the one that we're using as a benchmark. So the let me go, but yeah, there was a special issue of climatic change, one of the prominent journals in the field, where in 2014, they published these narrative scenarios. They described them. What do they mean? And these narrative scenarios were the result of a long process of deliberation of economists, climate science community, sociologists. They had conferences, they asked for public consultation, and they nailed it down. But from these climate scenarios, we see already how to deal with the ambiguity and misspecification, because I can pick up. Once I pick up a concentration pathway and a socioeconomic pathway, I have resolved my ambiguity. And once I pick a model, I have resolved the misspecification. Then we have to deal in modeling the equations, I have to deal with fat tails. Fat tails are important for us doing debt sustainability because debt unsustainability is an extreme tail event. So I need a way to model fat tails. And likewise, the climate science community, they realize because of tipping points and non-linearities that you want to look at the fat tails. So again, that's an area where we converge. Acute and chronic effects, we will get them out of the integrated assessment models. And to deal with the tragedy of the horizons, to quote the former governor of Bank of England, our models take a very long horizon, like we look 50, 60 years ahead, which as Angel remembers when we were doing the work together, it was a big topic of discussion. How long horizons do we need? Well, typically, it's 4 or 5 year business cycle to do the sustainability analysis. But when you look at climate change, you need really long horizons. And we have one of the first models that really took a very long perspective. Okay, so here is the scenario matrix architecture as published in this special issue. Combinations of the SSPs on the top, RCPs on the rows, SSPs the columns. I did the color coding here. Everything green is basically sustainable. Like these combinations here show that the concentration of gases will remain more or less, will remain within the Paris Agreement. Black is not feasible. If we follow SSP3, we will never get here. Yellow is kind of, is yellow, not good, not catastrophic, but a problem. Red is the catastrophic scenarios where things are out of control. And finally, SSP5 could also bring us to do nothing. So this is the matrix architecture that I am arguing the sustainability analysis should focus on the green cells, maybe a couple of the yellows here, to understand how various combinations of SSPs and RCPs affect the fiscal position of sovereigns. The numbers are the numbers of currently available integrated assessment models that converge. So for the green cells and the yellow cells here, I have models from the climate science community that will help me understand the effects of climate on growth, the effect of climate on damages, so I can do my debt sustainability analysis. And this is what we did, working with Andrea Consiglio, a colleague from University of Palermo for many years, and Johannes Emmerling, who I understand works just across the street from where you guys are. It's a research center in northern Italy and University of Venice. Johannes has been the developer of the RISE 50 model and the WIDGE model that we are going to use. And with Andrea, this is our paper on debt sustainability analysis that we are going to use. So let me keep an eye on my time, on my timer here. Okay, so let me say a few words about the economic problem and the model. We want to look at a sovereign that issues debt, we call it X, to finance its debt. But is financing its debt considering the correlated financial, economic, and fiscal variables subject to debt sustainability controls. Debt sustainability controls means that debt stock and the debt flow should be bounded, should not blow up. And there is a feedback loop. The decisions you make how to finance your debt determines the debt stock. The debt stock will affect the interest rates because of premia, risk premia or term premia, and in turn, the interest rate affect the financing decisions. So there is a feedback loop that we model, and there is a tension between debt stock and debt flow. You go long term, tends to be more expensive, but it's easier to finance, to refinance. If you go short term, it's cheaper, but it's more difficult to refinance. You create refinancing risk. Now, how do we model the uncertainty? We're going to model uncertainty by using scenario trees. So we develop a time and state description of the economy, where every point on this tree is a potential state of the economy at a given point in time, where by state, I mean a combination of interest rates, primary balance, economic growth, and I calibrate this tree, and here is now the interesting part. To the extent I don't have climate change, I can look at historical data and calibrate my tree using historical volatilities, correlations, and fat tails. This is the problem of risk. It's uncertainty, but I have the probabilities. I can write down a model and fit a scenario tree that has the same moments like the observed historical data and has averages converging to my expectations, like inflation will reach 2% steady state, okay? But when it comes to climate effects, this whole tree can be shifted, can be shocked. And it will be shocked based on the narrative scenarios. So on this tree, I can now do my debt dynamic equations. Here is my first equation, is the debt dynamics. Everything now is indexed by N, by the scenarios, okay? And I can write my flows, and I can do anything I want on this tree to do stochastic debt sustainability analysis. Debt stock, debt flows, okay? And I can write down my debt sustainability optimization model. Over the tree, I want to optimize the cost of debt financing or the expected value of the cost of debt financing, subject to constraints on the gross financing needs, on the flow, and on debt stock. Now, I want my gross financing needs to be bounded by some value that the market can absorb, and I want the rate of change of debt to be bounded. I don't want my debt to keep increasing. Or basically, I want it to be stabilized or to decline if it's a highly indebted country. So this is kind of the sketch of the model. So we go back to the tree, the scenario tree. We simulate the distribution of debt stock at different points in time. Again, you see how things are shifting up, but also the volatility is becoming bigger. And you also see the fat tails that are created. This is the debt stock. I can do the same for debt flow. And I want to put some bounds on these distributions. But how do you put a bound on the distribution? Well, that's where we need to introduce a risk measure. So another innovation we did in our paper was not only to simulate the two key variables on the tree, but also to use a risk measure. And basically, we're using the conditional flow at risk. We look at the distribution of the flow. We fix a quantile like the 95th percentile. We look at the average of the tail, and we want to limit the average of the tail. So if you go back to my model here, what this constraint is actually saying is that the expected value of the tail of gross financing needs should be bounded by a threshold. So the worst case, if you want, or the worst 5% should not be too high so it can be financed. Okay, so with this machinery in place, we could run the model. Again, this is the Italian, the original data I gave you. We calibrate the model for Italy without climate risk, and we obtain the pink shaded fund chart. And then we take our tree, we shock it under a specific cell from our scenario metrics. Specifically, I take SSP2 and RCP 2.6. Let me remind you what these are. Here we are. So I take this here. I take one of the models here, which means middle of the road socioeconomic pathways, the Paris Agreement temperature, run two models, the WITCH model and the RISE 50 plus model. Using these two models, I shock my tree and I obtain the blue line with WITCH and the dashed line with RISE. So now we have an analysis for a specific cell. I mean, you may ask what happens in other cells. We will get to it. But for a specific cell, here is the situation for the case of Italy. Okay, now misspecification, to make the point, here is an example of the average growth as percent of GDP using several models from the IASA database. So the point here, there seems to be consensus in the direction of travel among the various models, but there is quite some variability in the actual amounts. So they have one model that they consider the benchmark, but there are several models around it, so there is some variability. And again, this is something we can integrate in our analysis, and we should integrate in our analysis. Why? Because we do not want our results to be model specific. There is an important difference when you do the sustainability analysis on a 3 or 5 year horizon for a funding agency, for the European Stability Mechanism or the Ministry of Finance, and when you look at climate risk. In the former case, you want to get accurate information. In the latter case, you want to get a rough estimate that you feel confident in it. So I prefer, instead of using one number and get a precise estimate, I prefer to say, well, this is somewhere the range where it will be. So given the ambiguity about the data and the misspecification of the models, I prefer to live with this ambiguity than give a precise estimate, because my precise estimate will demand that you accept the model I'm using. And if you ask the developer of the model, he will give you a long list of assumptions he has. The long list of assumptions do not cast a shadow. Is the prediction any reasonable? It is. Can you trust it is precise? It is not. And this is exactly what you see here. Many different models, they're all telling you the same thing, the same picture, but the values are different. So we need to work with ensembles of models. Now what we did today was, I was twice in Milano today. Once was in the morning because we were finalists with a group of PhD students from Palermo. They implemented this model, and we were finalists in a Bank of Italy and G20 competition, fintech competition on solutions for climate risk. And we developed together with my colleague, the gentleman in the blue shirt is my colleague Andrea Consiglio, and a team of PhD students. We developed an interactive tool to implement what I just showed you. And today they announced the winners. We were not a winner, but we were a winner. We made it to the finals, so we were very happy and we learned a lot. So let me very briefly show you this 1 minute slide simulation. Let this load for a minute. Okay, so I'm going to push run here, and what you see here is the variable debt to GDP here, right? With confidence interval 75%. Under RCP 1.9, this is the more aggressive Paris Agreement, 1.5 degrees temperature, SSP 1, and let me run the simulations, and now you see how the color code is changing with time. So you see how some countries are becoming more red, their debt to GDP is becoming worse and worse, and some countries are becoming green. Let me here change, I will go to SSP 2, and now I get a warning that the combination of SSP 2 with RCP 1.9 is not valid. So I have to go and change RCP to 2.6. If we follow SSP 2, we cannot possibly go to 1.5 degrees, we will go to 2 degrees. So now we have a new simulation. Let me see if I can run it, right? And again, you see the evolution. I mean, it's a prototype, but it makes the point. We can also select, you see now it's becoming more red. The countries are becoming more red because the temperature increase is higher. We can also select an impact function. So you get the point that we're trying to have an interactive tool to showcase the interaction between climate change and their dynamics. So to conclude, and I think we're fine with our time. So the conclusion, to go back to my policy paper, I show that, or I argue that we need to do something, and I show that it's possible to do it. What I argue should do is to engage in a scenario-based systematic assessment of climate risk to public finance, to model the transition risks and model mitigation and adaptation costs, including damages and social costs. I argue that fiscal authorities should mainstream climate risk analysis in public finance. Budgetary plans should account for climate risk. We need to look at risk-sharing instruments like GDP-linked bonds, catastrophic bonds. How do you finance this debt that's climate-related? So I need to look at risk-sharing instruments. Third point, the problem is global, or at least regional. It's not country-specific. So we need collaborative action by the institutions that are responsible for fiscal stability, the same way we see collaborative action between the central banks for financial stability. What does this collaboration involve? It means finalizing, deciding on a scenario metrics architecture. I gave you my preferences here, but I want the high-level institutions to engage in dialogue and decide what are the right combinations of socioeconomic pathways and RCPs that you want to analyze for their sustainability. Then we need the integrated assessment models, regional models, focusing on Europe for the case of Europe. So we need to build some confidence in the models instead of me as a researcher running various models, and to mandate the sustainability analysis with climate risks, so that climate risks are having an effect, they're having an effect early on, they should be mandated. The sustainability analysis with climate risk. And finally, the country fiscal authorities should disclose the climate exposure of public debt. It's important for investors. Let me go back briefly to make a quick comment. Oops. Okay. You see here, I said, you see when does the blue line start deviating from the red? About 2030, 2040. So this is when we start seeing the effects of climate change on public debt. The same way the colleagues from Cambridge said from 2030, you already see the ratings being affected by climate change. The same way I see the deviation somewhere between 30 and becoming more pronounced by 40. Okay. So with this, I'm going to leave it here. Thank you very much. I don't know why I have the Russian version here. I should have had the Italian version here, but thank you very much for inviting me, and look forward to the discussion.